Hey guys, welcome back. This is Frank and welcome to our IGCSE COSI chemistry revision videos. Our current unit is C5 Detective Chemistry. So today I'd like to talk a little bit about paper chromatography. So this is one of the sections that are a bit boring in terms of there's really nothing much to talk about. But anyway, I'll try my best. And I hope today's video is going to be a short one because yeah, there's nothing much to talk about. But anyway, let's first start by defining what chromatography is. All right, so chromatography is since we're in the detective chemistry unit, it's a way to uh, separate separate substances present in a mixture. Okay, so that's the definition of, not the definition, but like sort of what chromatography does, and basically it's just a way of separating, let's say, different inks or uh, just general substances from a mixture, and yeah, chromatography will not only give you like a rough idea of how many in terms of the number of different substances present in the mixture, but also the amount of each substance. So and with a proper RF value, which we will talk about later, you can even if you look it up, you probably could even see like which exact substance that is. But anyway, the general steps of conducting a paper chromatography is, I'll do that later, is so the method. All right. So this is how you would set up the apparatus. I would move this. I would move this diagram here to give us some space to work with. And all right. So now here is our diagram, and I have actually met a problem that asks us to kind of make a label diagram of paper chromatography. So you should be able to know this. So this is what we call the solvent. Actually, that's two down. So here, solvent. All right. So solvent is basically in this case water. So like some the liquid part that is being used in chromatography, and we would need of course chromatography paper. So chromatography paper. All right, and from here we can see that this line in the actual chromatography experiment, you would see this roughly because the water would kind of make the paper yellowish or something, so you can see a very distinct line. So this is what we call the solvent front, or the kind of distance that the solvent has traveled, because chromatography paper is made of a special substance or a special material that would absorb water and would kind of bring this water upwards. So this is why it would be able to separate the mixture, is because it kind of brings the mixture upwards, and because different substances would travel different distances, you would be able to see what's inside the mixture. All right, so yeah, that's our chromatography paper, and above it you would roll it kind of on a splint or on a pencil or whatever to kind of hold this paper up, and you have to make sure that this line, this pencil line, must be above the solvent. All right, so this is very important. Must be above the solvent. This is because if the pencil line was the ink spots on them have been like submerged or immersed in the solvent itself, then it might dissolve and you might not be able to get a very accurate result. So it the ink spots has to be above the solvent, but the solvent has to be touching the paper. I mean, the paper has to be like the bottom part of the paper has to be inside the solvent. And yeah, that's about it. And you would put a beaker outside, obviously, and that's basically the setup for this experiment. And I should just leave it here for now. And now, talking about method, talking about method, we have several steps using this setup to carry out a paper chromatography experiment. So first of all, you would prepare English. Remember, prepare like the paper. So, for example, cut it to the correct length. Cut or roll. I don't know. Roll over a splint or whatever. So like maybe a better terminology to use is cut or attach or fold around the splint or a pencil or whatever. And the second step is to draw a pencil line. So draw a line on paper. So roughly about 2 centimeters is enough. But yeah, depending on the size of the paper. And you would place ink spots. So if you have, so these ink spots, you have to put it exactly on the pencil line. So maybe you would use a thin glass tube. So that's another piece of apparatus you could use. So like it sort of looks something like this, like a very mini straw, but glass and thin glass tube. And this is used to pick or carry the ink itself. And then we would pour our solvent into beaker, and actually, as I said, we have to make sure that the solvent is below the paper, I mean the pencil line. So as I said, you cannot completely immerse the pencil line into the solvent. And we have this setup, and we have to leave for 15-20 minutes until leave until solvent reached until solvent reach about top of paper. So the solvent front is somewhere over here. And the final step is you could remove and dry. Okay, so basically this is usually how you would carry out an actual experiment. And I will just put this over here for a second so that it's not in the way. I will rearrange this later, don't worry. And okay, so moving on, the next subtopic I would like to talk about is what is called RF value. Alright, so it is still on the syllabus, but I've not seen one for a long time, so I don't know. Perhaps it's still there, but it's just not very. It doesn't come up very often. However, you still have to know that, of course. So an RF value is basically you use your distance of substance over distance of solvent. Alright, so the distance traveled by the substance over the distance traveled by the solvent. This is very easy to and very intuitive to understand. And I guess I can give an example. So let's say if you have a chromatography paper that looks like this, right? All right, so then you have your dot over here, uh, and the result is kind of like this, okay? And the solvent front is, let's say, over here. All right, and we know that this is not a mixture; it's only one substance because when we look at this, it only has like one thing separated. So, oh yeah, and for this label diagram, by the way, you have to show separation in order to get a mark. So that is very important. And yeah, for this one, the RF value is calculated by using this distance. So let's say 3.5. Uh, actually, let's say it's 4.5 centimeters. Uh, centimeters. So this is this distance from. Actually, I'll move this down a bit so that it's easier for us to actually see. So I'll move this down. Alright, so suppose this is your result, and this is 4.5 centimeters. So this is 4.5 centimeters. And this is, let's say, 5 centimeters. So 5 centimeters. And now, to calculate the RF value, it's very easy. You just do substance over solvent. So you would get something like in this case 4.5 cm over 5 cm, which gives us, actually I'll write it in the color so that it's easier to see, 4.5 cm over 5 cm. Oops, 5, which gives us 0.9. So this 0.9, 90% is the RF value. And let me see if I can find a table. Alright, so here is a pretty neat table of RF values that I found on the internet, and I've put right here. And yeah, this is basically how scientists would use an RF value to determine what kind of substance something is. So from here we can see that in this particular research, there are some different distance traveled, and from this distance they calculated an RF value using distance of substance divided by distance of solvent, and from this RF value they compare to pre-existing published data. So these are values from previous researchers, and they compare it and they decide that, oh, maybe these, because the values are quite similar, maybe this is what is present. So this is also how we would use a paper chromatography to determine which substance is which by looking at their RF value. All right, so that's all for today. So we talk about how we carry out chromatography. We talk about how to draw a label diagram for it, and we also talk about calculating RF values. And yeah, that's all for today. And next time, I hope we're gonna be wrapping up with some different some other techniques like separating and purifying and distillation and stuff like that, and we would be done for the unit. So thank you, and see you soon. Bye.